So let's continue. You really just need to practice these a lot. It's a little bit tedious with the amount of work you have to do, but it is fairly straightforward. And you just have to be slow and careful and double check your work. So now we're going to distribute again. This 3c is going to go to all three of these terms. And then this 2 will go to all three of these terms. So in total, we'll end up with 6 of them. So let's start with 3c times c squared. So that's 3c cubed, because you have 3 c's multiplied together. 3c times minus 6c would be minus 18c squared. And 3c times minus 4 would be minus 12c. Then we do the 2. So plus 2 times c squared, so plus 2c squared. And then 2 times negative 6c would be minus 12c. And 2 times negative 4 would be minus 8. And at this point, we just combine like terms. So there's only one cubic term. And it looks like there's 2 square terms. So that would make it minus 16c squared. And then we've got 2 terms with c. So that's minus 24c. And at the end, we've got this constant term, but there's no other constant, so we'll just tack the minus 8 onto the end of this. So when you multiply these together, you do get a third-degree polynomial. Now, one other thing to notice is that the highest power of your polynomial is going to come from multiplying the 2 highest power terms. So it came from the 3c times the c squared term. And right away, you can tell, since these are the 2 highest powers, and this is to the first and that's to the second, that when you multiply these out, you're going to get a cubic. And likewise, you can notice that from the problem above. The highest powers of p here were both squares, and so when you multiplied those terms together, you got a p to the 4th term. So just by looking at the problem, you can generally tell the degree of your product for that polynomial. So let's move on to a problem with the area model. So this rectangle has a height of this polynomial term here and a width of this binomial term here. And we need to find the area of the entire rectangle. Now, they're using an area model here to multiply these out. So you could just do this algebraically like we did with the last 2. But another method for multiplying these polynomials, or polynomials by binomials, is to use this area method. And essentially what they're doing is they're just putting the binomial on top, c squared and then plus 1, and then splitting the 2 terms. And then they're putting the cubic polynomial down the side. So you get your c cubed, your plus 6c squared, and your plus 2c. And again, they're going to split the box for each of these divisions. And then when finding the area of these rectangle, you're just going to find the area of each of these individually and then just add them all up. So that's another way to approach this problem. A lot of students prefer this because it does organize it nicely. This is also known as the box method. So let's use that rather than multiplying it out algebraically. So for this blue box, we have c squared times c cubed, which would be c to the 5th. You got 2 c's there, 3 more there, and so in total you're multiplying 5 together. Now this column will be simple because we're just multiplying everything by 1, so that's c cubed. This is 6c squared, and this is 2c. And over here, c squared times c squared is c to the 4th, and we got a 6 that's attached to it. C squared times 2c would be 2c cubed. Now we can just combine like terms. So notice we only have 1c to the 5th and 1c to the 4th term. So we got c to the 5th plus 6c to the 4th. Then we have our cubic terms. You got 1c cubed and 2c cubed. So in total we got 3c cubed. Then we got the square terms. There's only one of those, and there's only one constant term. So we'll just write I'm sorry, not a constant term, but one linear term. So we have plus 6c squared and then plus 2c to finish it off. So this polynomial, this 5th degree polynomial, will be the area of this rectangle, or in other words, it's the product of multiplying these 2 expressions together. And let's continue. So we've got another area model problem. And for this one, now that we understand the area model, I'm not going to draw out a new picture, but basically we just had to find the area of each of these 6 boxes and then add them together. So let's do that very quickly. So we have a squared times a squared, which is just a to the 4th. 2a times a squared is 2a cubed. 5 times a squared is 5a squared. We have 3a squared here. 2a times 3 is 6a. And 5 and 3 make 15. So now we combine the like terms. We've only got one a to the fourth term. We've only got one a to the third term. Then we got our squared terms. We got 3 there and 5 there, so in total we have 8a squared. And then we only have one linear term and one constant term. So we have plus 6a and plus 15. And so this right here, this fourth degree polynomial, will be our answer.